We are continuing our study of functions with quadratics. So a quadratic function is a polynomial of degree 2. So any polynomial where the highest term has x squared in it. Now in terms of the graph of a quadratic function is going to be a parabola. And so here are a couple examples of what a quadratic function could look like. So in this first one, we have a parabola that is facing upwards. And you can see here that red point there is the vertex. It also happens to be the x-intercept, and it also happens to be the y-intercept. In this next one, we have a parabola that opens down. And here we can see very distinct points, the vertex up at the top there. We see the two x-intercepts, and we see the one y-intercept. In this last one, we can see that this one has a vertex and it has a y-intercept, but it does not have any x-intercepts. All right, so a couple of things that we can make note of now. Notice the graph of a quadratic function can open up or down. It always has a vertex. It either is going to be a max or a min, depending on if it's opening up or opening down. And it has exactly one y-intercept. Now, if you look at the examples that we just saw in those last three, we can see that for each of those there was a y-intercept, whether or not it happened to coincide with an x-intercept or the vertex as well. As for the x-intercepts, you can have two x-intercepts, you can have one x-intercept, or you can have none at all. So that is one thing that is going to vary depending on the quadratic function you're working with. Next, we have what's called the axis of symmetry. So a parabola is always going to be symmetric about a line that goes through the vertex, and we call this line the axis of symmetry. Now with quadratic functions, there are three forms of a quadratic function that we will see. So the first form is called transformation form. It's also known as vertex form. And as you'll see, the reason why it's called this is because you can either see it as, well, we can see all the different transformations on that function, or you can think of it as we can easily identify the vertex in this form. So this is the form, f of x equals a times x minus h squared plus k. Next we have polynomial form. This is also known as standard form. In this case, we have everything, you can think of it as multiplied out, so you can read it as a polynomial. This is f of x equals ax squared plus bx plus c. And lastly, we have x-intercept form. And as its name suggests, you can easily identify where the x-intercepts are when it's in this form. So we have f of x equals a times x minus s times x minus t. Now we're going to go through each form and we're going to talk about how we can find the vertex, the x-intercepts, and the y-intercept given that form. So let's start with transformation or vertex form. Alright, so to find the vertex, as the name suggests, it is very easy to find the vertex in this form. It is simply h, comma, k. Now note that in the form, you have a times x minus h squared plus k, and there's a minus in front of the h. This means that if you have x minus 3, h is equal to 3. If you have x plus 4, that means h is equal to negative 4. So the one thing that you have to remember is that the h is going to be kind of the opposite of what you see, although it is in fact simply x minus h in the form. Now to find the x-intercepts, if you set y equal to 0 and then solve for x, you will end up with x equals h plus or minus the square root of negative k over a. Now you can see here that that gives you two values because you have the plus or minus. However, if what's under the square root is equal to 0, then you'll just have one x-intercept. And you'll notice that under the square root at this point, we have it looks like it's a negative, but we don't know what the value of k is. So if k itself is positive, then yes, you'll have a negative k divided by, and then if a is also positive, now you definitely have a negative under the square root, in which case there would be no x-intercepts. Next, to find the y-intercept, you would set x equal to 0. If you set x equal to 0, you end up with ah squared plus k for the y-intercept. All right, let's do an example of a problem given to us. So for the function f of x equals 2 times x minus 3 squared minus 4, find the vertex and the x and y intercepts. Then sketch the graph. Okay, the first thing I'm going to do is I'm going to identify what a, h, and k are. So in this case, we have a is equal to 2, h is equal to positive 3, and k is equal to negative 4. Okay, now that we have that, we can now find the vertex and the x and y intercepts. So the vertex is h comma k. So now that I've already taken h and k from the equation, I can say that the vertex is at 3, negative 4. Next, the x-intercepts, that's h plus or minus the square root of negative k over a. So that would be 3 plus or minus positive 4 over 2. So 3 plus or minus the square root of 2. And then the y-intercept, this is going to be ah squared plus k, so that's 2 times 3 squared plus negative 4, which is equal to 2 times 9, so 18 minus 4, which is equal to 14. Now we can go ahead and graph this function using all this information that we just found. So we have a vertex at 3, negative 4. Now the x-intercepts are at 3 plus root 2 and 3 minus root 2. Now, in order to actually graph that, you'll probably want an approximation. Square root of 2, I believe, is about 1.4, so 3 plus 1.4 is about 4.4, and we can do the same thing with 3 minus root 2. So we have a point there between 4 and 5, and a point there between 1 and 2. The y-intercept is at 14. Now, obviously, that goes off the grid, but that gives you a good idea of what this parabola is going to look like. So we can go ahead and sketch that. Here's our axis of symmetry, if that helps. Sometimes the axis of symmetry can be helpful when you don't feel like you have enough points to work with, and you can simply reflect across that axis of symmetry. All right, let's go on to polynomial form. So polynomial form is f of x equals ax squared plus bx plus c. Now to find the vertex, this should look familiar from Algebra 2. So we have negative b over 2a for the x-coordinate. And then once you found the x-coordinate, you are going to plug in negative b over 2a back into your function f. That's what that second part after the comma means. It means whatever you got for x, you want to plug back into your function f, and that will be your y value. Now to find the x-intercept in polynomial form, this is actually just using the quadratic formula. So this is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, and then lastly, the y-intercept, which is the easiest one in polynomial form, is simply, well, if you set x equal to 0, then your y-intercept is going to be at c. Okay, let's go ahead and do an example in polynomial form. So we have f of x equals x squared plus 2x plus 3. We're going to find the vertex, the x and y-intercepts, and then sketch the graph. So I'm going to first start off by identifying a, b, and c. So a is equal to 1, b is equal to 2, and c is equal to 3. So for the vertex, we are going to first find negative b over 2a. So this would be negative 2 over 2 times 1, which is equal to negative 1. So that's your x-coordinate. Now we're going to put negative 1 back into our function f of x. to get our y coordinate. So this is going to be -1 squared, make sure you put that in parentheses before you square it, plus 2 times -1 plus 3. So that would be 1 minus 2 plus 3, which is equal to 2. All right, so that means our vertex is at -1, 2. Now for x-intercepts. So x-intercepts, we are going to use the quadratic formula. Now when you use the quadratic formula, you're going to end up finding that you have a negative under the square root. When that happens, that means there are no x-intercepts because you have a non-real number. All right, and then lastly, we have a y-intercept at whatever c is equal to, in this case, is 3. All right, let's go ahead and graph the points that we have. So we have a vertex at -1, 2. No x-intercepts. Now, even though that seems like it's not a lot of information to work with, it actually tells us exactly what this is going to look like. So if we have a vertex there at -1, 2, and we know there are no x-intercepts, we know in fact that this has to face upward. Otherwise, if it faced downward, it would go through the x-axis. All right, we also have a y-intercept at y equals 3, so I'll put a point there. And then here's where the axis of symmetry can help. We can use that y-intercept and we can reflect it across the axis of symmetry and get another point. That's probably enough to get you to have a good sketch of the parabola here. And that's it. So just note that even though you are not able to find any x-intercepts, that doesn't mean that's not helpful for you in order to graph the function. In fact, it helps us determine which way the graph is going to open. All right, the last form is x-intercept form. This is f of x equals a times x minus s times x minus t. Now to find the vertex, this is going to be s plus t over 2 for the x coordinate. And then once you find that, see after the comma, we have f of s plus t over 2, which means you take whatever you find for the x coordinate, and just like you did with polynomial form or standard form, you are going to plug the x coordinate back into the function to get your y value. Now also notice that s plus t, if you look back into the form, we have x minus s, x minus t. So similar to transformation or vertex form, where you have that x minus h, you can think of it as s and t are always going to be the opposite. So say you had x minus 3 and x minus 4, then s and t are equal to 3 and 4. For the x-intercepts, all you have to do is set each set of parentheses equal to 0, and then solve. So you'll end up with x equals s and x equals t. And then lastly, for the y-intercept, this is when x is equal to 0. So this would end up being a times s times t. And the reason why it becomes s and t is because when you multiply negative s times negative t, it ends up being positive. All right, the last example. F of x equals -1/2 times x minus 4 times x plus 2. We're going to find the vertex and the x and y intercepts. So first I'm going to identify a, s, and t. So a is -1/2, s is 4, and t is -2. All right, so let's first start off by finding the vertex. So we do s plus t over 2, so 4 plus -2 over 2. And that's equal to 1. And now that we found the x-coordinate, we are going to take that x-coordinate, plug it back into the function. So this would be -1/2 times 1 minus 4 times 1 plus 2. Okay, this ends up being positive 4.5. So your vertex is at 1, 4.5. All right, the x-intercepts, we take each set of parentheses, set them equal to 0, so x minus 4 equals 0, x plus 2 equals 0, or in other words, x equals 4 and x equals negative 2. And the y-intercept, this would be a times s times t, so negative 1/2 times 4 times negative 2, which is equal to 4. All right, let's go ahead and put this all on our graph. So we have our vertex at 1, 4.5. We have x-intercepts at 4 and negative 2. We have a y-intercept at 4. All right, you can draw that axis of symmetry in going through the vertex, and we can sketch our graph. And that's it. So you'll notice that for each form, there is maybe one part of finding the vertex or the x-intercepts or the y-intercept that makes it particularly easy. So typically we would think that in transformation vertex form, the vertex is the easiest thing to find. For polynomial form or standard form, the y-intercept is the easiest part of this to find. And for x-intercept form, the x-intercepts are typically the easiest to find.